Hello and welcome to another AQA GCSE 8300 series revision video. This is the second paper in the higher tier of the June 2017 past papers, and we're picking up in question 21, which reads: solve 5x squared equals 10x plus 4. Give your answers to two decimal places. Okay, now I think the standard method that they want you to work with here is to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. But some people are better at memorizing procedures than learning formulae. So I want to give a more procedural approach to this question, just in case you get to the exam and your mind's gone blank and you've forgotten the quadratic formula. So this method's called completing the square, and we can have a look at this. But this is only, well, you can use this if you can't remember how to use the quadratic formula, or if you just can't remember the quadratic formula. So we'll rearrange this equation. I'll start off by dividing everything through by 5, which gives me x squared is equal to 2x, 10 divided by 5 is 2, plus 4 divided by 5. So that's 4 over 5. Okay, so all I've done is divide everything through by 5. And now I'm going to gather like terms. I'm going to bring the x squared across. Oh, sorry, the x term across. So this is x squared minus 2x is equal to 4 over 5. So I've got my x terms on one side and my number terms on the other. And here it might be tempted to try and factorise the x out, but because it doesn't equal 0, it's not going to be terribly helpful to factorise out the x. But this looks incredibly close to a perfect square. Now, if you remember that a plus b squared is equal to a squared plus b squared plus 2ab, that 2ab bit means the way to check for a perfect square is to halve the x term, or halve the coefficient of the x term, and then square it. So if we halve negative 2, we're going to get negative 1. And then if we square the negative 1, we're going to get positive 1. So x squared minus 2x plus 1 is a perfect square. And since we've added 1 to the left hand side, we need to add 1 to the right hand side to keep the equation balanced. So if we make the right hand side 4 over 5 plus 1. Now we've got a perfect square, we can factorise this as x minus 1 squared. So again, all I've done is halve the middle term there. And that's equal to 4 over 5. I'm going to make the denominators the same, so I'm multiplying the 1 by 5 over 5. 5 over 5 is still 1, anything divided by itself is 1, so this hasn't changed. But now I can add the numerators, you see. So this is x minus 1 squared is equal to 4 plus 5 is 9, so this is 9 over 5. Now all I have to do is square root both sides. So this is x minus 1 is equal to, and remember there's a positive and a negative root, so this is positive and negative square root of 9 over 5. Now if I just add 1 to both sides, I get x is equal to 1 plus or minus the square root of 9 over 5. And if I plug that into my calculator, okay, so I've got my calculator, so I'm just going to type in 1 plus, and the way I do this on my calculator is to use brackets, open brackets, 9 divided by 5, close brackets, and then inverse squared to get the square root. Your calculator might work differently, which is why it's so important to use your own calculator. And if I hit equals, that's 2.3416, which I can round up to 2 decimal places to 2.34. So x equals 2.34, or, and remember we've got to do the negative part as well. Okay, so I've got my calculator, so I'm just going to type in 1 minus, open brackets, 9 divided by 5, close brackets, inverse square, equals, and that's negative 0.34. Okay, so I hope this video was helpful. So if you do get a quadratic equation and you do forget your quadratic formula, all is not lost if you can remember how to complete the square. Okay, I'd like to wish you every success with your exams, especially if you're taking them this year, and good luck with your revision. And I look forward to seeing you